Light amplification. I'm sure by the time you guys see option, you will definitely know the answer to pick. Claire, what is laser? Light amplification by stimulated emission of radiation. That's laser. Radiation, laser. And there are so many uses of laser. Do you remember? The WAEC student, this one can come out in WAEC. Even Jamb can come. You know, so many applications. One of them is for cutting metals, for cutting iron, cutting steel. We also have laser surgery, medicine, can use it. They can use for drilling hole into a region. Okay, let's move. Number what now? Number 7. Let's try this question. Light of wavelengths. Light of wavelengths. 4.5 times 10 to the minus 7 meter. Light of wavelength 4.5 times 10 to the minus 7 meter is incident on a metal. Is incident on a metal. Is incident on a metal resulting in the emission of photoelectron. Is incident on a metal resulting in the emission of a photoelectron. Is incident on a metal resulting in the emission of a photoelectron. Resulting in the emission of a photoelectron. Full stop. If the work function of the metal, if the work function of the metal, if the work function of the metal, if the work function of the metal is 3.0 times 10 to the minus 19 joule, if the work function of the metal is 3.0 times 10 to the minus 19 joules, 3.0 times 10 to the minus 19 joules, full stop. Calculate the energy of the photoelectrons. Calculate the energy of the photoelectrons. Energy of the photoelectron. We are given speed of light. Speed of light C 3.0 times 10 to the power 8 meter per second. And then our H Planck's constant 6.6 times minus 34 joule seconds. Let's try it. Bossy, what do you get? You solve it. Martins, what do you get? You can't solve it. Olumide. Eh? Who is true? Yes. What do you get? Oh, yeah, now. Yes, how would you find kinetic energy? KE. If you go back to your note, you see the formula there. KE equals light energy supplied. Is that what you are taught to? Minus what function? So our KE, our light energy supply is what? HC over lambda. Go and check your notes. Minus what function? Or you can say HF. HF. What's the H that they gave us? H 6.6 times what? Minus 34. What's our velocity? 3 times 10 to the power 8. Are we? What's the wavelength? Are we given? 4.5 minus what's the work function they gave us? 3 point, are you sure? 3.0 times all this jargon, what do you get? 4.4. 4.42 times what? Minus 3.0. Some people did not subtract, they just stop here. You are wrong. Answer is 1.42, Abi. That's minus 19 joules. Let's go. We're revising. Number number 8. Number 8. An object is placed at a distance. An object is placed at a distance. An object is placed at a distance x. An object is placed at a distance x. That uncle in a gray shirt is sleeping beside Moyo. Uncle, wake up, collect your money. An object is placed at a distance x from a converging lens of focal length 20 centimeter. An object is placed at a distance x from a converging lens of focal length 20 centimeter. 20 centimeter. Full stop. If the magnification, if the magnification of the real image if the magnification of the real image formed by the lens is 5, if the magnification of the real image formed by the lens is 5, comma, calculate the value of x. Calculate the value of x. Oh, yeah. Let's try. And nobody should be missing coin like this in Adams College. Calculation on lengths, all these V. Class, what's the answer? Can you some of you missed it again? You like to make mistakes sometimes. Oh, yeah, read the question. Let me hear. An object, distance x. Okay, that's your U, Abby. Oh, yeah, go on. Yes. 20 cm, yes. Real image, that's plus what? Is it 5? Good. Because it's a real image, that'll be plus. So our U now, what's U formula? F into what? 1 over M. And what's that F? 20. 1 plus 1 over 5. So that'll be 20 times what? 6 over 5. 5 here, 1 here. So what's the answer? That's your X. 24. This is 24. Eh? Anything converging, F is positive, whether it's mirror or lens. Go and check your notes. Anything, once you see the word converging, now plus, whether na mirror or lens. Yeah, let me see who can get this one. Number what now? A loaded spring. A loaded spring. A loaded spring is set in simple harmonic motion. A loaded, a loaded spring is set in simple harmonic motion. Full stop. The force that tends to restore the load. The force that tends to restore the load to its equilibrium position is the force that tends to restore the load to its equilibrium position is option A, adhesive. Option A, adhesive. Option A, adhesive. Option B, elastic. 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 Option C, frictional. Frictional. Option D, gravitational. Gravitational. Oh yeah, someone should think. Peace. Welcome to class. You want to try the answer? Pick one. Let me see. Don't shake it. It's welcome question. Welcome back question. Okay. Want to try? Yes. Gravitational. Who else want to try? Yes, Martins. Elastic. Who else want to try? Frictional. Okay, okay, con 4. People have picked gravitational, elastic, frictional. So I'm looking for adhesive. Gravitational. Why for my hand? Adhesive. Gravitational. Yes. Pardon? Frictional. Good. Yes. Gravitational. Okay. I love that. The last jam, many people don't have many calculations. They have a lot of story. So all these story questions, we cannot take them for granted. Some of you are still writing jam tomorrow or Monday. Oh yeah. Now what they are saying is your body begins to swing like this. Now this one is called equilibrium position. These are the extreme ends. Okay. That boy at the back there is talking. He's talking. So if I move this one to this place and I release it, when the body tries to go this way to the equilibrium position, even when it passes there, if we get here again, we want to come back to this place. They are saying that force that make it to come back like this is called restoring force. It restore it back to this place. Want to go back, go back. Is a restoring force. Then I said that restoring force that bring it back is called what? You know, that force that bring it back to this place is elastic force. That's the word, elastic. Elastic. And that's why we wrote, there's a formula like this. Restoring force. Look at this. So restoring force equals elastic force. And what is restoring force? That's MA, mass times acceleration. And then elastic force is what? E or KX or KE. From there, you now have our A now be KX. I just want to remove the all over M. So our A now be minus K over M X. But in physics, this K over M is omega squared. And that's where we got that formula from. Omega squared. So that's it. So this acceleration. So our A, we are omega square root of K over M. So the force, the restoring force is the same thing as elastic force, not gravitational, elastic. So restoring force is MA, and then elastic force is minus KX. So when the M go down, that's what we have. Kyra, yes, you can stand beside your colleague. Don't obstruct people. So the answer is not gravitational, but elastic. It restore it back to the place. Okay, next question. Yeah, I love this again. Which of the following graphs? Which of the following graphs? Which of the following graphs gives the correct relationship? Which of the following graphs give the correct relationship? Which of the following graphs give the correct relationship? Correct relationship between energy, between energy, correlation between energy and mass, between energy and mass, between energy and mass, when mass is converted to energy, between energy and mass, when mass is converted to energy, when mass is converted to energy. Oh, yeah, I'm giving 4 graphs now. So you have to pick one. So sketch the 4 and pick one. A, B, C, D. Energy, mass, energy, mass, energy, mass, energy, mass. So you have this one, we have this one, we have this, then you have this. So pick one answer. Pick one answer. Yeah, you want your answer to be A, raise your hand. A, no one is raising hand. When you find the Dockers online, what did you get? What was your answer? And Ifeoluwa, Florence also, Afabi, Fayoshe, Shopade. People should put your answer A, B, C, D. Let me see. Okay, Fabi. Okay, class. The answer is A. Raise your hand. You must raise your hand for one. Oh. You know me. If you don't raise your hand at all, I'll tell you to stand up and define some topics so I can expose your village people. Let me start again. You want your answer to be A. You think your answer is A. Raise your hand. What of B? Raise your hand very well. Okay. You're online. Some people are picking B too. What of C? Okay. Put down your hands. What of D? Kindness. What is your answer? You didn't raise your hand. What did you pick? Cosi. Energy. Class. What is the question? Look at the question. The question says what? Which of the following graphs gives the words between energy and mass when mass is converted to energy? That's what they call the S thing. Energy is M delta 6 M is delta. What is that formula with only right? Energy. Delta M C squared, have we? Delta M C squared. Look at it. So this formula for energy. So with this formula, what is the relationship between energy and mass? Eh? Directly, the answer is B. That's all. But if they say energy and C, energy and C will not be this one. But energy and mass, energy is the times C squared. The relationship. C is constant. Velocity of light is constant. It doesn't change. 3 times 7 per 8. So it's like saying energy. Because this one is constant. C is constant. So energy and mass are directly related. Next question. Number what now? You will draw again. So the answer is B. I'm sure those are B that got B. You just like any line that passed through the origin. Nobody say you know them. I'm going to get past it. Once a graph pass through the origin, I be the answer. Okay. At least you guess right. Draw. Arrow here. X. Y. W. Z. Right. The diagram illustrates. The diagram illustrates. The diagram illustrates an object moving. Diagram illustrates an object moving in a circular path. Diagram illustrates an object moving in a circular path. PATH. Moving in a circular path. Moving in a circular path. Moving in a circular path. At constant speed. At constant speed. At constant speed. Full stop. At constant speed. Full stop. Which of the arrows indicates? Which of the arrows indicates the direction of linear velocity? Which of the arrows indicate the direction of linear velocity? Direction of linear velocity. Option A, Z. Option A, Z. Option B, W. Option C, S. Option D, Y. Oh yeah, when a body is going in a circular motion, I've taught you before. For a body in a circular motion, the velocity is always tangential. So the answer is Z. Abby, some people did not get it. You're just guessing. So the velocity is always tangential. If you get it, to be like this. Tangential. If you get it, to be like this. Tangent means it just touches the circle. Not in that part, not outward. Tangential. So the answer is Z. So velocity in a circular motion is always tangential. Right. Which of the following materials does not serve? Which of the following materials does not serve as a safety device in electrical circuits? Which of the following materials does not serve as a safety device in electrical circuits? Does not serve as a safety device in electrical circuits. Option A, connecting wires. Option A, connecting wires. Option B, switch. Switch. Option C, fuse. Fuse. Option D, earth wires. Earth, E-A-R-T-H. Earth wire. Earth wire, E-A-R-T-H. Earth, aye, wire. Yeah. If you miss that one, just come here for blue. Furekumi, what do you pick? What is the? Favor. Favor. That's your name, Abby. So I've known your name now. Favor, what do you think should be the answer? I know you are not around when we did all those things. You see, Willie, what you go pick if you see something like this in the exam? See me. Fortunate. Samuel, connecting wires. That's the answer. Connecting wire. That one is not a safety anything. No. Connecting wire. What is option A? Connecting wire. What's option B? Switch. Sometimes when you discover that there's something that will switch itself off when they see danger. When something is on like this and it saw danger, it just switch itself off on its own, automatic. So that switch is a safety device. We're not praying for that. Say, I taught you one of the classes, I think, my memory. There's a fire outbreak in this house. Oh, the first thing to do is to switch off the total power supply to that building. If you have, we're not praying for that to happen. Maybe TV catch fire or this one. The first thing to do, just go to where the power surge is. Hey, you run to that place. Pew. Once there is no more power, that means you have taken away the fuel that will ignite more explosion. So the switch is very important. It's a safety device, switch off. And if you go to the side there, you see a switch that can take up. Some of the hostels who don't know that, take it up. Like there will be no more light in that place. Then there's fuse. Of course, we know that fuse is a safety device. When the current is too high, it will melt and cut you off from that. There was another one again. Earth wire, very important. There are some things in your house. Mommy, I touched the TV. It didn't shock me. I thought the fridge, our fridge, they shock. It is shock. Why? There is no earth wire in your house. As man, the AC they shock. Yeah, they found they shock. Oh. Because there is no earth wire. So the earth wires work is to convey excess charges in your room down to the earth. So you need earth wires as a safety device. Let's go. Next question. We are doing revision. Draw. So n is 4, n is 3, n is 2, n is 1. Minus 0.85 EV. Minus 1.51 EV. Minus 3.39 EV. Minus 13.6 EV. So I went to this place. Right. The diagram above illustrates electron transition. Diagram above illustrates electron transmission, electron transmission, electron transmission, electron transmission from energy level n equals 3, 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 energy level n equals 3 to n equals 1, energy level n equals 3 to n equals 1, energy level n equals 3 to n equals 1, full stop. Calculate the wavelength of the photon. 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 Wavelength of the photon. In bracket, E equals 1 EV, 1.6 times minus 19 joules. Then H equals 6.6 times minus 34 joule seconds.
Yes,
Then
ma'am.
C 3.0 times 10 by 8 per second. Now, what's the meaning of emission spectrum or emission spectra? What's the meaning of emission spectra? Emission spectra. Now, when you have, I know, come and say, emission spectra is talking about energy liberated when an electron fall from higher level towards lower level. That's emission spectra. So when you fall now, you are 3 before, you come 4 to 1. That's emission spectra. You know, the spectrum of light you emitted. Let's find our energy. Our energy will be what? E3. You are coming from 3, Abby. 3 to what? So we're going to have E3 minus E1. That's energy emitted. Oh yeah, let's go. What's your E3 minus 1.5? 1. What's E1? Minus 13.6. So that would be minus 1.51. What is minus times minus? Plus 13.6. What minus 1.51 plus 13.6? 12.09. EVIB. Or you convert to joule, what would that be? 12.09 times what? 1.6 times minus 19 joule. That's our energy. Oh yeah, what would that give us? What is 12.09 times 1.6? 19 points. 19.344 times minus 19 joules. But our energy is what? Energy is AC over lambda, Abi. So we're going to have AC over lambda will now be 19.344 times minus 19. What do we do? Cross multiply. We now have lambda times 19.344 times 10 per minus 19. What's your Planck's constant? 6.6 times what? Minus 34. What's your C? 3.0 times what? Times per 8. So our lambda will now be what? 6.6 times minus 34 times 3 times 10 power 8 all over what? 19.344 times what? 10 power minus 19. Calculator, what do you get? Everything. 1 point times 10 power minus 7. Eh? Classwork. Please, the boy beside me. You're not feeling fine, go and rest now or take medication. Don't sleep in my class. No, I won't take that. You're not feeling too fine. Go to the sick bay or you go home. As a guy, I won't be comfortable sleeping beside a fine girl. I won't. Because you're supposed to protect your teeth. The girl will be looking at you as if you don't get brain. How can you be sleeping? Classwork. A photon. Are you still writing? Okay, only one person. So you leave line. I only had one voice. Leave some lines. Omolekai. A photon is incident on a metal. A photon is incident on a metal. A photon is incident on a metal whose work function is 1.32 eV electron volts, whose work function is 1.32 eV 1.32 electron volts. Full stop. An electron is emitted from the surface. A photon is incident on a metal whose work function is 1.32 eV. Full stop. An electron is emitted from the surface. An electron is emitted from the surface. An electron is emitted from the surface with maximum kinetic energy. With maximum kinetic energy of 1.97 eV. With maximum kinetic energy of 1.97 eV. eV. Full stop. Calculate the frequency of the photon. The frequency of the photon. Calculate the frequency of the photon. Oh yeah, they gave us this one again. These two. So write them 1 eV. Give us this two. 1 eV, 1.6 times minus 19 joules. And H, 6.6 times minus 34 joule seconds. Oh, it's true. We may decide to find the. Okay, try it again. Some of you have not done it. Do it. Yes, oh, it's true. Only Zainab and two people. We just did a question like that today. I don't know why you guys are not. You guys are rusty. You have to dust the brain. So, okay, light energy supplied minus what function? That's K. light energy supply minus what function? How much KE are we given? Check. 1 point. Then this is light energy supply. What's the work function? 1 point. So carry this one here, 1.97 plus 1.32 equals E. Our E, add up, what do you get? EVIB. Well, you have to convert to joules, right? 3.29 times what? Times 10 per minus 19. Multiply this to what do you get? 5.264 times 10 per what? Minus 19 joules. We know that this formula is HF. Do we remember? HF. 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 And what's that H? Are we given H? So that H, 6.6 times minus 34. F, someone is standing and still sleeping. Equal 5.264 times 10 power 919. Kyra, are you still sleeping? Okay, also 5.264 times minus 19 all over 6.6 times minus 34. What's the final answer? 7.98 14. That's it. So the online student also got something from that. Messi, Lademi, Rhoda and Co. Drawing. Let me give you a question nobody can solve. If you get it, if you are the first to get it, 1K, you come forward and show me. A simple question, no? So 1K. And if I observe that all of you are not getting it, I can double the money. And a simple question. An object of weight 120 Newton. That means welcome there. An object of weight 120 Newton vibrates. An object of weight 120 Newton vibrates with a period of 4 seconds. Vibrate with a period of 4 seconds. When hung from a string. When hung from a spring. When hung from a spring. When hung from a spring. Full stop. Calculate the force per unit length of the spring. Calculate the force per unit length of the spring. Calculate the force per unit length of the spring. Let's try it, everyone. Let me see who can try. So also I have to bring your notes here. Let me see. I can see your answer from there, SF. The first to get it. Where's Abikoye? No, Ifeo, the brother. Among the boys who know Abikoye. Nobody. Where is he? Pardon? He went. You saw him today, but I don't know where he is. Michael or Daniel, please come. Was he in math class? No. Was he in math class? Is he a science student? Please call HM Emmanuel for me. Is he writing WAEC? No. Yes, 1,000. Nobody want to get money. Should I double it? Yeah, who is true? Bring it. Or tell me your answer. Raise your hand if you are true. What do you get? 29.6. That's correct. Let me see. That's a good one. This working. But I will still give it a shot. So where is your first by length that you did? Where is first? Where is length? F by N. Where is F? I don't see anything where you do here. Yeah, you don't get an answer for nothing. I don't know how you did that baracadabra. I'll give 1K nevertheless, but I can't see your working. If I'm going to be 1K, that's theory, for example. Out of 10, I may just give maybe 6. I can't see what you have done. But at least I'll give you 1K. It's not a big deal. Now, that's the importance of some of the things we do in class that some of you don't listen. This morning now, when we are talking about restoring force, I derived one formula for you. Go and check. Restoring force. What formula did I write? I derived omega somewhere. What's that omega I gave you? Eh? I gave you, so even know right time. It's like we are here to play. So our omega, angular velocity or angular speed, is square root of km. And in your physics, you have been told that omega is 2 pi f. Square root of k over m. Who remember that f is what? 1 over t. So we're going to have 2 pi all over t. Now be square root of k over m. I can imply. I can say 2 pi. I want to derive another formula for you. Square root of k. Square root of m. So t root k equals 2 pi root m. Our t will now be what? 2 pi root m over k. Do we agree? Listen. The force per unit length they are asking for is k. That's all. So what they're asking for is k. Is k. So I just want to show you another formula like this. So how do you know that's what they're asking for? See your Hooke's law. What's Hooke's law? F is what? K EIB. So what's your k going to be? F over E. Force per length. That's your k. So when he has to find force per unit length, they're asking for k. So this is another formula you should store in your head. And then, which one? Okay, these two. I'm just trying to help you with some formula. All right, let's put the value now. What's RT? Check the question. What's period? 4. What's pi? 3.142. I think we are given weights. What's weights? So if weight is 120, what's mass? 12 kg. So I have 12 over k. So now 4 equals 6.284. Root over k. This one will come down. 4 over 6.284. Martins, do you know Abikoye? Who know Abikoye? Raise your hand. Oh, yeah, you help me look for him around in the compound here, not outside. Oh. Quickly. Go on quickly. Check. Because that boy has a potential to become more serious boy. I know him. I've been seeing red flag all around him. Only that I don't want to talk yet. He has potential to be wild and unserious. That's the first brother. So before the parents, the family will lose him totally. And the father is a doctor, medical doctor. Oh yeah, calculator. 4 divided by 6.284. What do you get? 0.63. Square both sides. You know, 0.63, 65. Also, I don't need to go through all this rubbish. Oh. When I just want to derive formula for you. Now we 12 over k. What is this one? Square. 0.4051. Gloria, I've been looking for you since to come and do revision. Oh. I'm Vera, I can't find you people. It's 12. So our k will be 12 over what? 0.40 divide. What do you get? That's it too. Newton per meter. Agu Obina. Where is Agu Obina? Agu. They say he's writing exam by 2. Jamb. I'm sure you know now. Doesn't know, should start running. You know. Emmanuel, do you know Abikoye? Abikoye, that fat boy. What is other name? Lekon. Lekon Abikoye. Eh? He's downstairs. Go and bring him for me. That boy is a very, very notorious boy. Oh. I want to help me monitor him. He's a very notorious boy. He has signs to become wild also. So that's what we can do to help him. Let me check whether you can see him downstairs. Follow that boy that went to look for him. Have you seen his name? Abikoye Lekon. You know him? Yes. Is it Diamond or Emerald? Where is he? Emerald. It's an Emerald. So look around, check downstairs and look for him for me. I'm bringing him here. And to give him 12 strokes. Okpankere. Okay, we're revising for those who have exam tomorrow and possibly on Monday. How many have we solved? How many questions? 14. 15, good. Let's go. Next question. Are we through with this? You don't forget that formula or this one. Some of you are reading exam tomorrow or Monday. Period is 2 pi. Many of you are used to 2 pi L over G. L over G. That's correct. But we also have 2 pi M over K for a spring. For a spring. Right. The material used, number 14. 16. The material used to slow down. At least everybody should get this one and smile. The material used to slow down the neutrons in a nuclear reactor. To slow down the neutrons in a nuclear reactor. Yeah, your 1K before I forgot. Sorry. Oh yeah, the material used to slow down the neutrons in a nuclear reactor is option A, boron. Option A, boron. Option A, boron. Boron. Option B, copper. Option B, copper. Copper. Option C, graphite. Graphite. Option D, uranium. Uranium. Class, what's the answer? Yay. Class, what's the answer? To slow down, you have to use graphite. Then to stop the reaction, you have to use what? Boron. Boron. To halt the reaction, to bring it to halt, boron. To slow it down, graphite. That's good. The answer is graphite. Another question again. Oh yeah, let's see who can get this one. A 500 Newton box. Where's the boy? Abikoye. Come here. A 500 Newton box. Come with your physics notes that I'm teaching and the maths we did today. A 500 Newton box. Man, I come, go to my car, go and bring cane at the boots. A 500 Newton box. Rest on the horizontal floor. I said you bring, I didn't say you should kneel down yet. Bring your notes, the maths and the physics. Check my boots, you see cane. Eh? You didn't come for the maths class. What about the physics class? Class, how many questions have we solved? 16. You only wrote number 1 and you left class. Pardon? You want to go and do bread and egg? That's what you want to do. I started the class by 10. This is 12. So bread and egg will take. So the crowd is so large. It's like Jamb class that the crowd is much. So out of 16 questions, you have done 1. Even the one you didn't write the answer well, because I explained all the 4 options. You only did 1 and you were left class. What about the math class? Who sent you there? Where is the math we did before they called them? Because we were doing math before they came to call them. Yeah. So when you came, you went to do bread and egg for 2 hours. How many questions have we solved? 16. We have solved 16 questions. You wrote only 1. So 16 minus 1. That's the number of strokes of cane you're going to have. Yeah, 15. And you're going to remove your shed before. Because, quiet. Your dad, what's the profession of your dad? Medical doctor. So he was not trans when he was in school. He won't become a doctor. Can you kneel down very well? But that was not playing transit, leaving class, going for bread and egg for 2 hours. It won't be a doctor. Your dad is a doctor and you are frustrating your dad. They wanted to register you for NECO. I was told you went to meet the admin that you don't want the school. You want to go to a school where there is runs. That's the reason why you can leave class. That's why you don't want to do. People don't want to read. Thank you. Please, after today. My father is a doctor, but he wants to become area boy. He left my class. I'm sure when other teachers are teaching, he will not even be there at all. Because if you can leave Adam's class, when Adams is around, then other teachers, you not even care. A 500 Newton box rest on a horizontal floor. Rest on a horizontal floor. Full stop. A constant horizontal force is exerted. A constant horizontal force is exerted. Is exerted. A constant horizontal force is exerted. Is exerted on the box. A constant horizontal force is exerted on the box so that it moves through 8 meters. 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 It moves through 8 meters. Full stop. If the coefficient of kinetic friction, if the coefficient of kinetic friction, this is how to kneel down with one leg. Put it down. You don't seem to know me. If kinetic friction, if the coefficient of kinetic friction between the floor and the box, between the floor and the box, between the floor and the box is 0.22. Is 0.22. Calculate the work done on the box. Calculate the work done on the box. Calculate the work done on the box. Work done. Yeah, try it. This is simple. Let me see if you can remember some of the things we've been taught. So I repeat it. A 500 Newton box rests on a horizontal floor. A constant horizontal force is exerted on the box so that it moves through 8 meters. If the coefficient of kinetic friction between the floor and the box is 0.22, calculate the work done on the box. Work done on the box. Because it's true. What do you get? Oh, yeah. When we're in SS1, we're told that work done is first times. That's work done. That's work done. Force times distance. So work done by friction will now be frictional force times distance. That's it. So I will have to first find the frictional force. Claire, what's the formula for frictional force? Mu mg. Don't forget to mu mg. Mu mg. Meanwhile, this mg is weight. Do we remember that this mg is weight? Are we given weight in the question? What's mu? 0.22. What's mg, the weight? 500. Is that 110? Are you sure? 110 Newton. So work done by friction. Work done by friction. And have a frictional force. Frictional force times distance. That's it. What's our frictional force now? 110, Abby. What's distance? 8. So that's 880, Abby. Joules. So on the timetable, the official lecture will end by 12 for physics. That's why I'm doing physics. So by 12, some of you are Jamb students who have Jamb exam tomorrow and Monday. You now start again. We now come forward for an additional chemistry revision. So some of you are not doing Jamb. Of course, you are free to go. Your class will end by 12. Nevertheless, if you join them, nobody's going to stop you, but your class ends 12. So you will go. Some of them are my daughters are already coming around for revision. I know and co. So you guys will move forward. We'll do revision for chemistry just to build you up. Okay, let's go. Next question. Number what now? 18. Number 18. In the hydraulic press, comma, the force F applied, is related to the diameter D. The force F applied is related to the diameter D by the force F applied is related to the diameter D of the cylinder by the force F applied is related to the diameter D of the cylinder by, I love this. If you know, we are not careful, you go miss some. Write the option and pick one. A F prime to D squared. B F prime to D. C F prime to D minus 1. And then D F prime to D minus 2. Pick one answer. I'm not asking for your reaction, so do your classwork. Because some of you are also worse than that. He's not feeling any pain. It's a big boy. I didn't want you to remove your clothes because of your steez. So I want to protect it. Okay, how many of you pick A? Raise your hand. Raise it very well now. Why are you afraid? You don't want people to know that you miss it. Raise your hand. You pick A. Okay, put down your hands. You chose B. Raise your hand. Okay. You chose C. Raise your hand. Raise it very well. Okay. You chose D. Raise your hand. Okay. I didn't choose anyone. Raise your hand. My brain is dead. Therefore, I didn't choose anyone. Okay. I'm happy that at least some of you who are still doing exam tomorrow are learning one or two things because you are missing some questions. And you learn. In hydraulic press, what do we have? Pressure is constant. That's the meaning. Hydraulic press. So people don't look up. Oh. They don't see the reason why they got to do and they miss it. Do what we have in our hydraulic press. Pressure is constant. Pressure, the pressure generated at one end of a fluid is transmitted equally to the other end, confined container. That's Pascal principle of pressure transmissibility. Pressure is constant. In other words, force over area is constant. That's the meaning. That's what we said. Force 1 over area 1 equals force 2 over area 2 equals force 3. Like that. Be looking at the board though. That one at the back is sleeping. And the boy. Oh, sorry, Nagel. And she looks like a boy. Or she's a girl. And behaving like okay. Look at this. F over A is K. What does that mean? Look at the board though. It means F because it implies F equals KA. It means F proportional to area. That's the meaning. And the measured diameter. Area is pi r square or pi d square over 4. So the answer is A. Can you see? Can you see? Sixth question, no? So those that raised their hand, there are only 4. And one of them was like this. I'm not sure. I'm not sure. But A, I'm not sure. I think it's A. Right. You can't do revision and not have anything to learn or anything to gain. Okay, we move to another question. Right. Water waves have a wavelength of That's number what? 19. Okay, we'll just do 20 and then we'll stop. Water waves have a wavelength of 3.6 centimeter. Water waves have a wavelength of 3.6 centimeter and speed of 18 centimeter per second. And speed of 18 centimeter per second. And speed of 18 centimeter per second. In deep water, water waves has a wavelength of 3.0 centimeter and speed of 18 centimeter per second in deep water. Full stop. If the waves enter a shallow water, if the waves enter a shallow water, if the waves enter a shallow water with wavelength of 2 centimeter, if the waves enter a shallow water with wavelength of 2 centimeter, with wavelength of 2 centimeter, full stop. Calculate, sorry, comma. Calculate the speed of the waves. Calculate the speed of the waves. Calculate the speed of the waves in the shallow water. Calculate the speed of the wave in the shallow water. Now let's try it. Speed of the wave in the shallow water. Those of us online, please let's try and solve that. Some of us on the YouTube in particular. Miriam and Oshinawa or Efran, please, let's see. Let me see how many, what you can get. Work it out. Tumeshetu, Phoebe, Oladipupo, Kukoyi, Hazan, Shijoke, Kamela. Let me see what we are going to get. Kamela, Adebisi, Austin, Jeremiah. Let's try that. And some of you are on YouTube. Can click on the like button there. Yes, oh, it's true. Cynthia, what do you get? 10. The online student, what do you get? Let me see what you get. Those are on YouTube. Okay. All right. Some of you got that correctly. Oh, yeah. What did they mention? What are the media they mentioned? What's the first medium? Eh? Water, deep water, and what? I just say refractive index and velocity in deep water over velocity in, okay, is it light? Is it water waves? So velocity, if it's water, water waves, velocity in shallow, velocity in deep, wavelength in shallow over wavelength in deep. For light waves, we prefer less dense medium over denser. Velocity in air over velocity in the medium. Velocity in air over velocity in the medium. So shallow is having a higher velocity than deeper water, isn't it? Check. What velocity in shallow water? Unknown. What velocity in deep water? 18. What's the wavelength in shallow water? What's the wavelength in deep water? 3.6. That's it. Oh. Some of you that reverse it, don't worry, you still get it. So we're going to have 3.6 Vs equals 36. So velocity in the shallow water will now be 10. Is that correct? 10 centimeter per second. So many of you got it. So it's already 12. So we'll take the last question for physics. Those of you that have exam by 2, want to wish you all the best. Those who are going. But we'll still do chemistry revision. And we are releasing other people also from the wire class. But we'll still do chemistry here, 12 to 2 or 12 to 1:45. Those who are just back now, my Nika and others, of course, do revision for you to encourage you. The peace, the kindness, the others. Let's go to number 20. Right. Calculate the instantaneous value. The instantaneous value of a current. Calculate the instantaneous value of a current. Of a current. Of a current in AC circuits. Of a current in AC circuits. If the root mean square value is 15 amperes. If the root mean square value is 15 amperes. If the root mean square value is 15 amperes. And phase angle. And phase PHASE. And phase angle is 30 degree. And phase angle is 30 degree. So we can all get that. That's simple. Now, what to find instantaneous current? They give us root mean square value, Abi. Class, what relation between root mean square value and I naught? I RMS is what? Over root 2. That's it. So our I naught will now be I RMS root 2. What's the root mean square current they gave us? How much? 15. Now 15 root 2. What is root 2? 1.4142. That's 21.21. Is that correct? So we want to find I. I is always what? I naught sine theta. Right? That's I. I naught sine theta. I naught sine. So that would now be 21.21 sine what? Sine 30. Class, what is sine 30? Half. So what's the answer? 10.65. 10.6 amperes. So the YX student, don't forget there is chemistry practical tomorrow. What time? 9 to 12. If you're not doing YX, maybe you are for some of you are for NECO, some of you are for GC, some of you are even for next year YX and Jamb. So don't bother to come tomorrow for the practical because the material we're going to do, because it's going to be really practical, full practical. And we don't want to come and distract those who are doing YX on Tuesday. So those who are coming tomorrow are those who have YX. So we are free to go now. The Jamb students who are here for revision, let's move forward. I didn't plan for this. Let's try question 1. Question 1. Which of these sorts, the class will start now and end by 1:45, God of the Muslims, or 1:30? I think 1:30, God of the Muslims. Which of these sorts will give a precipitate when reacted with NaOH solution? Which of these sorts will give a precipitate when treated, which of these sorts will give a precipitate when treated with sodium hydroxide solution? Which of these sorts will give a precipitate? Please, if you have a chemistry revision, I don't want the class to be scattered. Move forward, or you can follow them and leave, please. I want the class to be compact. Not that we are scattered, one person there, 1.5 person there. No. I want to see all of you closer here. Which of these sorts will give a precipitate when treated with NaOH solution? Option A, ammonium chloride. Option B, aluminum chloride. Option C, sodium ethanoate. And option D, sodium carbonate. Pick one answer. Also, what do you pick? Glory, what do you pick? Abiko, be a good boy. You eh? I'm not smiling at you. Be a good boy. It's for your own sake. Oh. So be going, go and copy the notes and be serious. Okay. Now look at the question very well. The question says, which of the following, which of these will give a precipitate when treated with sodium hydroxide solution? Now, the basic concept is this. This sodium hydroxide solution, see how to answer question. Number one, sodium hydroxide solution can never in this world react with anything that has sodium. So picking C is totally wrong. Picking D is totally wrong, but they all have sodium. So even if you don't know chemistry, this idea I've just given you now has helped you to eliminate these two. That is all. That's one. Then number two, anything ammonium is soluble in water. All ammonium salts are soluble in water. So even if you don't know the confirmatory test for aluminum, I've given the answer already. You are sodium, you can never react with me. You are sodium, you can never react with me. You know. So the answer is B, aluminum chloride. And what precipitate will it give us? White was white precipitate. What are the guys that will give us precipitate with sodium hydroxide? Zinc ion, lead ion, aluminum ion. They will give us white precipitates. Calcium will also give us, but that one is insoluble. Abi, these are guys are soluble in SS. Mr. Adams, why are they soluble in SS? Because of the formation of complexes. Abi, soluble complex. Zinc will give us zincate complex. Lead will give us plumbate complex. Aluminum will give us aluminate complex. So that's that. How many of you have done your Jamb? I have seen your result. I am not writing Jamb again, but you're writing WAEC. Raise your hand. Raise it very well. You are not writing Jamb again. God bless three of you. How many of you are not even writing Jamb at all? And you are not writing WAEC and you are here. Ogwani, what are you writing? Are you writing this Jamb? This Jamb of this month? It's next year. Do you know what I'm saying? What I'm saying is that this whole class supposed to still wait for chemistry. Even if they have done Jamb, but because they are going to do WAEC, so they were going to do this WAEC, and they have chemistry 2 weeks time, they left. I intentionally tested them. I know they are going to fail the test because they are going to do chemistry in WAEC. And what is bad in knowing all this one? In fact, this one, they are still going to do this one in their WAEC practical, confirmatory test. That's how you test people, and that's how people fail you. For you to know that students are very unserious. We move to number two now. Number two. Everybody should try this one. Determine the pH. Determine the pH of a. Determine the pH of a 2.50 times 10 to the minus 5 molar. 2.50 times 10 to the minus 5 molar calcium hydroxide solution. 2.50 times 10 to the minus 5 molar calcium hydroxide solution. Calcium hydroxide solution. Oh, yeah. Are you true? Oh, yeah. Let's look at this 2.50. Now, anything that has to do with pH, you are interested in how many moles of the hydroxyl or the hydrogen ion is there. They give us calcium hydroxide. So that will give us calcium. Then you have OH. Very important. Very important. So this is aqueous. Aqueous and then aqueous. That's what we have. So here now, what is the value they gave us? 2.5 times what? And 5 molar. Now, because this guy is now 2, so his value will now be 2 times 2.5 minus 5. That's it, because of that 2 that you have here. So that will give us 5 times 10 to the minus 5 molar. That is concentration. And then PO, you cannot find PO without knowing POH, but it's hydroxyl. So POH is minus logarithm of hydroxyl ion concentration. So that will give us minus log of 5 times 10 to the minus 5. Now, in case you don't have calculator that has to do with this minus log 5, minus log 5, minus log 10 to the minus 5. Log 5 is 0.6990, I think. Minus 5 log 10. In mass class, what is log 10? 1. So that'll be 5. Abby? Is log 5 0.6990? Good. So what that give us? 4.301. That's POH. But what they want us to find is P. That's POH. They want to find pH. Class pH plus what? Equals how much? 14. So pH plus 4.3 would now be 14. So our pH should now be 14 and a 4.3. Subtract, what do you get? 9.7. pH plus pOH is always 14. Let's go. Next question. What the difference in electronegativity between what the difference in electronegative? What the difference in electronegativity? What the difference in electronegativity between bonded atoms? What the difference in electronegativity between bonded atoms decreases? What the difference in electronegativity between bonded atoms decreases? What the difference in electronegativity between bonded atoms decreases? Polarity of the bond, polarity of the bond, polarity of the bond. Option A increases. Polarity of the bond. Option A increases. Option B decreases. Decreases. Option C remain unchanged. Remain unchanged. Remain unchanged. Option A increases. Option B decreases. Option C remain unchanged. Option D reduce to zero. What the difference in electronegativity between bonded atoms increases? Polarity of the bond. I'm sure you all know the answer. Now, if you have two guys now, maybe they form a bond, AB, AB. Our polarity of AB, polarity of AB depends on difference in their electronegativity. Difference in their what? Electronegativity. Claire, let me ask you a question. If we are very far in a periodic table, we are far apart. In the same period, if we are far apart, what will happen to our polarity? Will it be very high or very low? I only have very, that's the only thing I had. Very, if we are far apart in the same period, what happened to our alternative value? Is it going to be very high or very low? Okay, let me give you the one that you can easily remember. You are here. You are here, group 1. You are Mr. Sodium. And then me, I'm here, group 7. Forget about the other one. I'm Mr. Chlorine. We can't form bond. If we form bond, what will happen to our polarity? Will it be very high or very low? Eh? Very high. Polarity means ability for you to form ions. Very high. But we are now here. I'm even here. I say I'm now Mr. Sulfur. I am Mr. Chlorine. In fact, we are neighbor. The bond between sulfur and chlorine, the polarity, will it be very high or very low? Very low. So the closer we are in the periodic table, the lower the polarity that we're going to have. But when we are far apart, that means our electronegativity difference is high. Then the polarity will be very high. So that's it. So the answer is low, decrease. I electronegativity difference, I electronegativity, I electronegativity difference, I electronegativity difference equals I polarity. That's it. Equals I polarity. Then low electronegativity difference, low electronegativity difference equals low polarity. Low polarity. So in other words, the further away we are in the electrochemical periodic table, the higher our polarity. Okay, let's go to the next question. What is the IUPAC name of the compound? What is the IUPAC name of the compound? What is the IUPAC name of the compound? CH3, CH2, CHCl, CHBr, CH2, C double bond OH. Oh, yeah, name it. What's the IUPAC name of that compound? Are we true? What is the functional group in the compound? Acanal. No, acanol. Acanal. So your name should end with what? Al. 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 So you now start from here. One, two, three. This is BRO, sorry. Four, five, six. When you are naming, you must name alphabetically, Abby. So what's the first thing we're going to say? Three bromo, four chloro, eh? Hexanal. That's it. This is bromine on carbon three. Three bromo, four chloro, hexanal. Oh yeah, another question. The hydrocarbon used, the hydrocarbon used, the hydrocarbon used in the production of styrene, the hydrocarbon used in the production of styrene is option A, ethine. Hydrocarbon used in the production of styrene is option A, ethine. Option B, propine. Propine. Option C, ethane. Ethane. Option D, ethane. Ethane. What's the answer? Styrene. Do you know the formula for styrene? Styrene, see styrene. You're going to have CH2 and CH. You know, so to have CH2. One of the hydrogen is now used. You now have benzene here. There's the formula for styrene because you see that in the exam. So that's styrene, or you have like the CH2, then have the phenyl ring C6H5. This styrene. So that means you can say that we can get styrene from where, class? What compound do we get styrene from? 18 now. This is 18. CH2, CH2. So the answer is 18. So you can get styrene from 18. Styrene can be gotten from 18. Let me give you some short note on that. The following are the uses of styrene. The following are the use of styrene. The following are the use of styrene. The following are the use of styrene. 1, it is employed for making plastic. It is employed for making plastic and paints. For making plastic and paints. Plastic and paints. Number 2, it can also be used for making synthetic rubber. I'm sure you have heard of synthetic rubber before. Styrene butadiene rubber, SBR. Used for making synthetic rubber. Synthetic rubber. So used for making synthetic rubber. And number 3, it can be employed as polyester. It can be employed as a polyester for packaging. For packaging. Polyester for packaging. Full stop. But the major use is that rubber, synthetic rubber. Call it SBR. The first country that manufactures synthetic butadiene rubber is Brazil. SBR. You know, they can make rubber. Don't forget that we have 2 types of rubber: artificial and what? Artificial and what? Natural. What is the major component of the natural rubber? Isoprene. Isoprene. Okay, another question, just revision. What is the IUPAC name of the compound? What is the IUPAC name of the compound? Yeah, write the compound name in your notes. Have you written the name? What's the IUPAC name of that? So you start with this. Sodium. 4 means what? Tetra. Anytime you say hydrogen end like this, don't say hydride though. Hydrido. Hydrido. Aluminates. Aluminate what? 3. Thank you. So how did they get 3? You can calculate it. So NaAlH4. Our sodium is 1. Aluminum, we don't know. X. Hydrogen, because serving as an hydride, minus 1 times 4. This is minus 1 times 4. And that's 0. So our 1 plus x minus 4 is 0. So we have x is plus 3. So we're going to have sodium tetrahydrido aluminate 3. Claire, what is the major function of these guys? What is the major work? What are they used for? If you don't see sodium, you have lithium. Pardon? Reducing agent, very good. They are very powerful reducing agents. So when you see that in the exam, the following can be employed as a strong reducing agent. That is it. So why? Because they are going to take oxygen from you and add it to this hydrogen and turn to water. You know, so it's going to remove oxygen from you and turn you to water. Okay, another question. Oh, yeah, let's try this one. Methane diffuses. Methane diffuses. Methane diffuses through a porous port. Cause are you okay? Yeah, you guys, I know you're no longer used to writing for some time. It's not easy. Methane diffuses through a porous port in 20 seconds. Methane diffuses through a porous port in 20 seconds. Full stop. What time will it take the same volume of sulfur oxide? What time will it take the same volume of sulfur oxide? What time will it take the same volume of sulfur oxide to diffuse through the same ports? What time will it take the same volume of sulfur oxide to diffuse through the same ports? To diffuse through the same ports. Oh, yeah. Are we true? Now, because they mentioned the same volume, the effect will not be a direct relationship because they mentioned the same volume. So just say time 1 over time 2 is equal to square root of molar mass 1 over molar mass 2. When you have the same volume, it's direct. When you have the same volume, it's direct. So if you have, is it methane dimension? So you have time for methane over time for SO2. Would that be molecular mass for what? Methane over what? Molecular mass for SO2. What's time for methane? Are we given? 20 seconds. What's time for SO2? That's what we are looking for. I think this guy is 16, Abby. Carbon is 12. For what about the other guy? 64. So I have 20 over T. What's square root of 16? Square root of 64. So 4 year, 1 year, 2. The answer is 40, Abby. So I have 40 seconds. 40 seconds. What is seconds? Right, next question. Which of the following? Okay, that's it, right. Right fast. Question number 6, I'll be 7. 8, good. Which of the following noble gases is used? Which of the following noble gases is used in photography? In photography, MRI, MRI imaging, photography, MRI, magnetic resonance image, MRI imaging, and satellites. So the following noble gas is used in what? Photography, MRI, imaging, satellite. Option A, xenon. Xenon, Xenon, xenon. Option B, radon. Radon, Radon. Option C, krypton. 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 Option D, argon. Argon. Yeah, pick one. Yes. Want to try? Everybody come they look down as if mosquito they for ground. Or tambolo they walk for ground. None of they look up anymore. Sonny, what do you pick? Anyone that pick argon has picked wrong answer. Anyone that pick radon has also picked wrong answer. Anyone that pick xenon has also picked wrong answer. And that is krypton. We use krypton in photography, MRI imaging, and satellite. All right. Xenon is used. Xenon. Just note NB. Xenon is used in medical imaging, medical imaging, and special lamps. Medical imaging and special lamps. Then radon is used in cancer therapy. Radon is used in cancer therapy and geological studies. Cancer therapy and geological studies. Geological studies. Cancer therapy and geological studies. Paragraph. Argon is used in welding. Argon is used in welding, light bulbs, and insulation. Welding, light bulbs, and insulation. Welding, light bulbs, and insulation. What about neon? What do we use neon for? Advertising lab, Abby. So you can write neon is employed in signboard, SIGN, board, signboard, comma, lasers and lightning, laser and lightning, laser and lightning, laser and lightning, laser and lightning. Okay, so let's leave that one. Right, I'm sure you have seen this going. I want to give you now before. Beryllium and aluminium have similar properties. Beryllium and aluminium have similar properties because they option A are both metals. Are both metals. Are both metals. Option B. Option B. Option B. Belong to the same group. Belong to the same group. Option C. Belong to the same period. Belong to the same period. Option D. Option D. Are positioned diagonally to each other. Oh, yeah. I just said, what did you the answer? It's good to see you again. Good. Anu, Okoyemi. Now, Anatu, Anotu, Peter. Now, what they mention in the question? Which metal did they mention? Beryllium and so look at this is hydrogen. Look at this guy here. Helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium. So let's forget about the remaining one. So these are this guy. Yeah. What is option A? But that's not enough. What's option B? Are they in the same group? Never. This is group 2. This is group 3. They're not in the same group. Oh. What's C? Are they in the same period? So the answer is D. Are we? They are diagonally related. Likewise, these two guys, lithium and magnesium. You know. So once you're like this, you are related. Boron and silicon, like that. So that's it. Carbon and phosphorus. Diagonal, we call it diagonal relationship in chemistry. Let's go. Next question. Which of the following radioisotope? Which of the following radioisotope is used to estimate specimen's age? Is used to estimate specimen's age, such as a tree. Specimen's age, such as tree. Option A, carbon 14. Carbon 14. Option B, phosphorus 32. Phosphorus 32. Option C, cobalt 60. Cobalt 60. 60. And option D, iodine 131. Iodine 131. Want to try? Yes. That is the answer, carbon 14. We call it radioactive dating. What do I call it? They can use to date your age. You know, but majorly specimen. If you have a tree, you have a rock, you can do carbon 14 to how old is that rock? How old is that material? What's the option B they mentioned? Eh? What do you use that one for? Eh? Eye blood, eye tumor, leukemia. Yeah. Some if you have challenges with your blood, you can use photoelectric too. And also to determine DNA constitution of the blood. So that's to do is medically used, you know, DNA constitution, cancer treatment, and all that. What's the other one they mentioned again? Eh? What did they use that one for? Cancer. They can also plant it in people at planting machine. Some people cannot breathe on their own. Every day you wake up, you must thank God. Some people cannot breathe on their own. So I mean they breathe using machine. Machine. You know, so if you have the privilege of doing that, then you should be grateful to God. What's the last one? What they use that one for? Goiter. To control some element of thyroid gland effect. Goiter. Okay, let's move. Next question. A quantum of electricity liberates call the Muslim will close around 1:30. Fatima, Fatia, when is Juma service? When is after 2? Who has something contrary? If your own is after 2, then we can close by 2. If you have anything contrary, let's know. Or we close by 1:45 so that I can have time to get there. It's revision. It's impromptu revision. Okay. What question am I give? Okay, a quantum of electricity liberates 3.6 gram of silver from a salt. 3.6 gram of silver from a salt. Some of you are not writing anything. You're just sitting down, looking at me. I'll send you out of class. Oh. If you are not offering chemistry, then go. What mass of aluminium will be liberated from a salt? What mass of aluminium will be liberated from a salt by the same quantity of electricity? What mass of aluminium will be liberated from a salt by the same quantity of electricity? Will be liberated from a salt by the same quantity of electricity. In bracket, aluminum is 27 and silver 108. Aluminum 27, silver 108. Are we true? Who is true? Right now. This electrolysis, second law, Abby. What they mentioned, silver and what? You can use the formula straight, or you can say number of mole of aluminium. Is it aluminium or silver? Come on, silver. Come first. Okay. Anyone? Yeah. Number of mole of silver, one number of mole of aluminium. Aluminum is having 3. It's carrying 3. So we're gonna have 3 all over 1. That's all. Aluminum they carry 3. Silver they carry 1. So I have 3 over 1. The number of mole is mass all over atomic mass. For aluminum now, mass all over atomic mass. So that was 3/1. Yeah, what's the mass of silver? Are we given? 3.6. What about the atomic mass? 108. What's the mass of aluminum? Unknown. This one called 27 is 3. So you have 3.6 over 108 times 27 over S is 3. 27 here, 1 here, 4. So now 0.9 all over X is 3. Is it 0.3? Is it 0.3? So 3X is 0.9. S is 0.9 over 3. S is 0.3 gram. What's the exam by 2 today? Anyone? Don't go and go late to Joe. No more third chance. Oh. Let's try next question. If 100 cm cube of 2.2, if 100 cm cube of 2.2, if 100 cm cube of 2.2, if 100 cm cube of 2.2 mole per dm cube, if 100 cm cube of 2.2 mole per dm cube, H2SO4 mole per dm cube, H2SO4 is poured into a bucket, is poured into a bucket containing 400 cm cube, is poured into a bucket containing 400 cm cube of water, is poured into a bucket containing 400 cm cube of water, 400 cm cube of water, and the resulting solution mixed thoroughly, and the resulting solution mixed thoroughly, and the resulting solution mixed thoroughly, mixed thoroughly, mixed thoroughly, full stop. Find the resulting concentration of the acid. Find the resulting concentration of the acid. Classwork. Oh yeah, we should be true. Favor what? Favor is a D, not the class. Yeah. Read the question. 100 cm of. So there is 100 cm. That's the initial volume. What's the initial concentration? 2.2 mole per dm cube. Oh yeah, was now poured into water. Abi, what volume of water? 400. That's not V2. Sure, you know. I was 100 before. They can't add me to water. So I mean the final volume will be 500. Some people have. So the final volume is 500. So that's the principle of dilution. Now to find a new concentration. Abi now. So the C1 V1 equals what? That's the principle of dilution. So our C1 is what? 2.2. What's volume 1? 100. What's C2? Unknown. What's V2? 500. So can have 500 C2 will now be 2000, 220 Abi. So C2 will now be 220 about 500. What do you get? 0.44 mole per dm cube. The acid has been what? Diluted. That's it. Right. Another question. Which of the following is not an electrolyte? Which of the following is not an electrolyte? Which of this following is not an electrolyte? Which of the following is not an electrolyte? Is not an electrolyte. Option A, sodium chloride solution. Option A, sodium chloride solution. Sodium chloride solution. Option B, sodium ethanoate solution. Sodium ethanoate solution. Sodium ethanoate solution. Option C, sugar solution. Sugar solution. Sugar solution. Option D, ammonium chloride solution. Ammonium chloride solution. Class, what's the answer? Sugar solution. Please don't forget, sugar, you know, an organic compound. Not only that, it's a covalent structure. Another question. Which of the following liquid would dissolve fats? So the following liquid would dissolve fats. So the following liquid would dissolve fats, FAT. So the following liquid would dissolve fats. Option A, hydrochloric acid. Hydrochloric acid. Option B, calcium hydroxide. Calcium hydroxide. Calcium hydroxide. Option C, kerosene. Kerosene. And option D, water. This is common sense, so you should all get it. Testimony, what do you think should be the answer? Kerosene, because fat is an organic liquid. Like dissolve, like. Very good. Next question. How many unpaired electrons? How many unpaired electrons can be found in phosphorus? How many unpaired electrons can be found in phosphorus? How many unpaired electrons can be found in phosphorus? Yeah, try that. How many unpaired electrons can be found in phosphorus? Phosphorus. Are true. You in glasses, are you true? Are true. Class, how many? What's the atomic number of phosphorus? 15. That's the first thing, though. So we're gonna have 1s2, Abby. 2s2, you'll be counting. This is 2 plus 2, 4. 2p6, 10. 3s2, 3p what? 3p6 call. How do you don't pass 15 now? 2, 4, 10, 12, 15. And using your half-bar principle, when you are filling electron, you have to fill singly, Abby, and your own rule as well. So you have 1, 2, 3. That's it. Oh. So the answer is 3 unpaired electron, not 1. No. You have to feed them singly. So the answer is 3. 3 unpaired electron. See, Willie, is it clear? Don't worry, you'll be taught. I'm happy you stay back. That's a good girl. Our exam is next year, WAEC and Jamb. And the WAEC student who have gone home, she stay back. That's how I begin to. I want to start mentoring small. I don't want to use word small because they are big. Those who are new now and are serious, start knowing you small now. So that when the when the big guns goes, you can have people to mentor and guide. Right. Next question. Number what? 16. That's good. The idea is 20, but right, SO3. This is a non-practicable equation. SO3 gas, so what's this oxide? Plus water liquid. And we have H2SO4 aqueous. What's a friend that wrote exam this morning, 8 o'clock or 6:30? I have a friend. So it's gone now. They've done it. What of 9 o'clock? You have a friend that did 9. So that's it. So it's going small. Don't be tense anymore. Remove the tension. Right. Given the heat of formation, given the heat of formation, given the heat of formation for SO3, given the heat of formation for SO3 gas, comma, H2O liquid, SO3 gas, H2O liquid, and H2O4 and H2O4 aqueous and H2O4 aqueous as minus 395 kilojoule per mole, as minus 395 kilojoule per mole, comma, minus 286 kilojoule per mole, and minus 811. Minus 811 kilojoule per mole, respectively. Respectively. Find the enthalpy change accompanying this reaction. Find the enthalpy change accompanying this reaction. Find the enthalpy change accompanying this reaction. Yeah, try it. Enthalpy change. Yes. What's the answer? Delta H is what? Summation of heat of the product minus what? Heat of the reactant. Now only H is for products. And the value is what? Minus 811. Then the reactant, SO3. What's SO3? Minus 395. And what's the water? Minus 286. So that would be minus 811. What's minus 395 minus 286? 81. So that minus 811. What's minus times minus? This is 81. What do you now get? 130 kilojoule per mole. So you have the product minus the reactants. Next question. Which of the following chlorides, which of the following chloride will exhibit, which of the following chloride will exhibit the highest ionic character, will exhibit the highest ionic character, highest ionic character, highest ionic character. Option A, magnesium chloride, MgCl2. Option B, calcium chloride. Option C, aluminum chloride. Option D, lithium chloride. Oh yeah. Which of them will exhibit the highest ionic character? Oh yeah. Who picked magnesium chloride? Raise your hand. Bimpe, what did you pick? Opaque calcium chloride. Opaque aluminum chloride. Opaque lithium chloride. Kindness, you didn't raise your hand though. Eh? Eh? Now, the solution of them show the words. Show the words. IS words. And then all of them are now chloride. They are now chloride. So that means our problem is not even the chlorine now. Our problem is the metals. In other words, which of them is the most electropositive of them all? Which of them will be willing? Because ionic bond is formed when what happened? When electron is transferred, Abi, from element having what? Higher electropositivity to an element having what? Higher electron affinity, not electronegativity. Element is transferred from me. Element that has a very high electropositivity with what? With low ionization energy. I don't need to even, you don't need to beg me before I give you electron. I am highly philanthropic. If you go and ask, all of you that are going to pick D, you are wrong, totally wrong. Don't know the size of lithium. See, hydrogen is here. Wait, who they here? Helium. Who is here? Lithium. Lithium. Look at lithium. Lithium is like this. Lithium can never give you any electron. Lithium will not want to go into ionic bond. Who can tell me why? Eh? Raise your hand. Why will lithium not want to go into ionic bond? Raise your hand. Raise your hand. Want to talk? Yes. What is closer to the nucleus? The outermost electron is closer to the nucleus. And what? Will be very high. This guy will not. Lithium cannot give all the chemistry I've been doing. Have you been saying lithium chloride? Lithium chloride. We don't see this one. We see sodium chloride often. Why don't we see this lithium chloride? Because the guy will not give you electron. Lithium is very small, and the smaller your size, the more stingy you are. Stingy. Why is the most reactive element in this group? Is who? In this group, who is the most reactive metal? Eh? Let's forget about the rubidium and cesium. In the first 20 chemicals, who is the most reactive of all these elements? Potassium. Why? Because it has the largest size and is willing to give electron. The bigger your eyes, or your size, the more philanthropic you are, the more reactive you are. If they have put potassium, then that would have been the answer. Potassium chloride. But it's not there. Then if they have put sodium chloride, that would have been another answer. But they're not there. Don't go and say because this one is in group 1. And so look at its size. Its size is small. So the answer is calcium chloride. So how do I now get the answer? You go back to your electrochemical. What's on top? Potassium. That's the most reactive metal. After potassium, who follow? Sodium. These guys are willing to go electron. Followed by who? And that's it now. That's his series. There's no even lithium there at all. Because the guy is very stingy. There's some people in the old said they can never give anybody anything in this world. Not even sugar. People know them. Okay, that's one of them, I'll be Cynthia. Not even sugar. Can I have some sugar? No. The one I have cannot reach 2 of us. And that's the end. So blunt. So lithium cannot give out. So you now ask, and listen to this question. No? They now change the question maybe tomorrow or Monday. Now say, to the following has the least ionic character. What's the answer? Lithium chloride, not aluminum. That's the least. It will not be this one. Least. Am I communicating? Why does he have least ionic character? Because the guy will not want to go into ionic bond. Will not want to give you electron. The guy has a small size. And the smaller your size, the stronger the force holding that electron. That's why in this place, lithium, sodium, potassium, this one has the highest ionization energy because of its small size. So as you are going down, ionization energy can be reduced and say, you want electron, please take. No stress. Yeah, it's revision. So sometimes you miss it like this so that I can learn. I'm checking time. Don't worry, I was going to release you. I mean, I don't want to release you because you have exam, but for Islamic rights, we have to do that. Let's go on. Next question. The substance that is oxidized, the substance that is oxidized in the reaction below is, don't worry, by 1:45, we'll try and stop. So we have about 25 minutes or thereabouts. Yeah, some of you are also not getting, you've forgotten about how to sit down for long. Now, your bumper don't they paying you now. You're not getting used to it anymore. Antinike. Right. The substance that is oxidized in the reaction below is, everybody should miss this. Sodium peroxide plus 2 water. 4 sodium hydroxide plus oxygen. I love this question. So that is oxidized. So make I give you option A, NO2O2. B, sodium hydroxide. C, H2O. D, oxygen. Don't rush, oh. Be calm and get it. Like, we all know the answer that cannot be correct, Abby. What option cannot be the answer? I can't hear you. And for those who are new students, B and D. All the one on the right cannot be the answer. So those ones are out. So you have to 50-50 now. Do you want to be a millionaire? Okay, 50-50 now. If the answer is A, raise your hand. After I've already done 50-50 for you, cannot still not get it. Raise your hand. A, raise it very well. Not like this. Kindness, not like this. Raise it like this. A. The answer is A. Okay, the answer is B, raise your hand. I didn't say the answer is A. Oh. I said if the answer is B, raise your hand. Okay, the answer is C, raise your hand. Okay. What is the question? What did they ask you? Eh? That is oxidized. So what's the answer? A or C? Hmm. A or C? Hmm. Let me show something. C plus H, you now have CO plus hydrogen. Class, in this reaction, who is oxidized? C, coke plus steam. Now CO, that's water gas. Who is oxidized? C is oxidized. Why? Eh? Oxidation is what? Addition of oxygen. What am I saying? Oxidation of what? Oxygen. Why reduction is what? Let's talk about hydrogen now. Addition of hydrogen. So this guy, they call hydrogen. We are go there. So this guy has been reduced. And if you are reduced, me, I'm oxidized. That's the answer. Water. Kindness, you miss some of you and Kosi. Yeah, you know, don't read 2 months. So that's it. So that's it. So this guy, when this guy added hydrogen to you, if I add hydrogen to you, I have reduced you. If I add oxygen to you, I have oxidized you. So if I add hydrogen to you, you have been reduced. If I add oxygen to you, you have been oxidized. So they add hydrogen to this guy, it has been reduced. Then this one has been oxidized. That's one way of getting the answer. Let's go another question. An element has two isotopes. 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 2010X, 2010X, and 2210X. 2010X and 2210X. Full stop. If the relative atomic mass of X, if the relative atomic mass of X, if the relative atomic mass of X is 21.5, if the relative atomic mass of X is 21.5, comma, find the percentage composition by mass. Find the percentage composition by mass of the 2210X. Of the 2210X. Percentage composition by mass of the 2210X. Yeah, try it. Glory, what do you get? Peace. What do you get? Okay, are you true? Who is true? Some people are sleeping. So you're afraid of blue. You are thinking it's blue. You don't trust me. So you have 20x and 2210. Now, they didn't give us the percentage by mass. So let this percentage be maybe X or Y, because we have X there before. Let's call it K. K percent. This one will now be 100 minus K percent. We are looking for that K. So relative atomic mass, RAM, will now be 100 minus K over 100 times 20 plus this one, K over 100 times 22 equals how much? That's it. Mr. How do you get 100 minus K? Total percentage will be 100 for the two of them. So that's it. So if you like, everything on our mass remain. So can I say 20 into 100 minus K over 100 plus 22K over 100 equals 21.5. I don't want to cut. So that'll be 2000 minus what? 20K over 100 plus what? 22K over 100, 21.5. So we're going to have 2000 minus what? 20K plus what? 22K. You find the LCM 100 equals 21.5. So we're going to have 2000 plus 2K equals 2150. I did see negative. So that would now be 2150 minus 2000. So 2K will now be, is that 150? So that's like 75%. What a question. Many of you are used to when they give you the value, they give you the percentage. Now ask you to find this one. They can also give you a ratio, maybe 1:3. But now they ask you to find a percentage. That's a good one. That's a good revision question. Shawa energy. Shawa hiding. Are you okay? You're okay. You did agree, Kavi. Okay, let's take a few more. By 1:45, we'll stop. So 30 minutes more. You will not feel, amen. Don't be strong. Don't be tensed. Be practicing deep breathing. We said it yesterday. It helps to calm the nerves. I could share. Let's go. Next question. Which of the following is not a property of hydrogen sulfide? Which of the following is not a property of hydrogen sulfide? Which of the following is not a property of hydrogen sulfide? Which of the following is not a property of hydrogen sulfide? Which of the following is not a property of hydrogen sulfide? Option A, precipitating. Precipitating. Option A, precipitating. Option B, acidic. 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 Option C, bleaching. 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 Option D, reducing. Reducing. I'm sure you all know the answer. Let me show you something. Look at this. Lead ethanoates plus iodine sulfide. Then I give you ethanoic acid 2 plus PBS. Now they can give you a reaction like this tomorrow, and they can ask you in the exam, what property is manifested by hydrogen sulfide? What property does hydrogen sulfide exhibit in this reaction? Eh? Any property? Precipitating. This is black precipitate. Black precipitate. So this is precipitating property. Precipitating property. Property. All right, let me give you another one. You now have sodium hydroxide, hydrogen sulfide. You can get sodium sulfide plus OMI, water. Make a balance them. 2. What property is exhibited by H2S here? I can't hear you. Salt and water. Acidic now. This is base. No be so. So that's acidic property. That means why doing sulfur can exhibit. And some of you are doing YK, they can ask you to write 3 major properties of H2S. I've already given you some of them. Precipitating property, acidic property. Now, you now have another one, SO2, gas, plus hydrogen sulfide, gas. You can't have water, plus 3 sulfur. 2 conde here. So let's balance it. 2. 4 hydrogen. Yeah. What property is exhibited by hydrogen sulfide here? Reducing property. Means hydrogen sulfide, I know they bleach. Oh. You know, it's only SO2 that can bleach. So the answer is what? Bleaching. I know they bleach. So some of you that have exam tomorrow and Monday, just dust your notes, build your confidence back. I said this when I was talking yesterday online, the Zoom conference we had. The result we have in your set is the best result ever in the history of Adams College. We have not released the result because we want you to do your own, and so you don't be under pressure. I had Femi got 397. I had Binkwe got 372. No. So we don't want to. I know some of you have seen some of those results naturally, but seeing it from our own status will give you more pressure than what you have had. So that's why we didn't want to paste any result. So just calm down and get the best. Let's go. Next question. There's some questions we have answered before. I think we can still answer them now. We are not going to write. We'll just be answering them. Especially the story. Because chemistry, you won't have calculation except 5. So listen to this one. Some of them don't need to write. Relatively high boiling point of alkanol are due to what? A, ionic bonding. B, aromatic character. C, covalent bonding. D, hydrogen bonding. Hydrogen bonding. That's it. And in general, an increase in temperature increase solubility of a solute in water because A, More solid molecule collide with each other. B. More solid dissolve with the evolution of heat. C. More solid molecules dissolve at higher temperature. And D. More solid dissolve with absorption of heat. What's the answer? Eh? What do you see? More solute molecule dissociate at higher temperature? No. The answer is D. Most solute dissolves with absorption of heat. Another question. A major effect of oil pollution in coastal water is what? A. Destruction of marine life. B. Desalination of the water. C. Increasing the acidity of the water. D. Detoxification of the water. What's the answer? Destruction of marine life. Another question. Water for town supply is chlorinated to make it free from A. Bad odor. B. Bacteria. C. Temporary hardness. D. Permanent hardness. Bacteria. Another one. A quantity of air was passed through a weighted amount of alkaline pyrogalol. An increase in the weight of the pyrogalol will result from the absorption of what? Oxygen. Oxygen. How many valence electrons are found in phosphorus? That has 3115. How many valence electron? 5. Valence electron means 2 8. Phosphorus has 15. So you have 285. This is a valence electron. So the answer is 5. No unpaired, though. They didn't mention unpaired. Valence. Yeah, we'll soon round up. Another question. What are the types of bond present in ammonium chloride? I taught you ionic, covalent, and dative Abi. All the three. Please watch out. That one is always coming in the exam. The three of them are always found there. Methane is a member of what homologous series? Alkane. Alkane. And it has CnH2n plus 2. Plus 2. Okay. The process of converting linear alkanes to branch chain and cyclic hydrocarbon by heating in the presence of a catalyst to improve the quality of petrol is referred to as what? Reforming, not cracking. Cracking is when you break down higher to lower. Reforming. I've just told you this one now. Polystyrene is widely used in packaging material for fragile object during transportation because of its A, lightness, B, low density, C, high density, and D, high compressibility. High density call. If it's too dense, then it will add weight to what you are doing. Low density is very light. Lightness and low density are almost the same, but low density is what we'll pick. The process of converting starch to ethanol is what? Fermentation. Fermentation. Ethane is passed through a hot soup containing organic catalyst to produce what? Benzene. To produce what? Benzene. Ethane turned to benzene. And that process is called polymerization. What is the name of the alkanol obtained from the production of soap? Glycerol. Glycerol. What is the name of the material we use for sorting out process? NaCl, conch sodium chloride. Brine. Abi? Brine. A few drops of sodium hydroxide solution was added to an unknown salt, forming a white precipitate, which is insoluble in excess. White precipitate, insoluble in excess. The cation likely present is A, zinc, B, lead, C, calcium, D, aluminum. Calcium, because zinc, lead, and aluminum, they are soluble away. A compound that gives a brick red color to a non-luminous flame is likely to contain what? Calcium. What color does potassium gives? Lilac. What does sodium? Golden yellow. Golden yellow. Don't worry, just calm down. Let us go rush through some few things. In a chemical reaction, the change in concentration of a reactant with time is what? Rate of reaction. The rate of reaction. Rate of reaction. Rate of reaction. Vera, you finish your exam? Come and tell us how the exam was. Vera. Come and tell us what that came out that I can remember. I know you have a magnetic brain, so you're going to remember. I think I should take you for lunch now since you are through, Abby. Adeze Onyanusi, Echi, Esin. Are they here? She said, what function came out? You know, that's what we have been doing since morning, you know, work function, all those things that we did. Work function was much. And I don't know why I was teaching you today. I can't see. I've given you our 4 questions today on work function. The lighting supply minus work function. See, organic chemistry came out. Thank you very much. So go and read organic chemistry. When you say organic chemistry came out, that means you didn't tell us anything that came out too. Organic chemistry is so wide, like island. It's 1:45, so we have to stop here. So we wish you all the best tomorrow. God bless you. Yeah, you have to respect the Muslim community in Adams College. Start your share, Abeg. Start your share.